7 teams play a soccer tournament in which each team plays every other team exactly once. No ties occur. Each team has a 50% chance of winning each game it plays, and the outcomes of the games are independent. In each game, the winner is awarded a point, and the loser gets 0. The total points are accumulated to decide the ranks of the teams. In the first game of the tournament, Team A beats Team B. The probability that Team A finishes with more points than Team B is m over n. Find m plus n. So essentially, this relatively prime positive integers means where m over n is fully simplified, a fully simplified fraction. Okay, so the complexity of this counting problem compels us to break this into cases. Now, A wins the first game. Let's break this into cases based on how many A wins of the remaining 5 games. If A wins, let me change the color to something you can see. If A wins 0 games, then B must win 0. Because A must finish ahead of B, and Team A beats Team B in the first round. If B wins 1, then it would be a tie. So to calculate this probability, let's think about how many ways there are for A to win 0. Well, there are only 1, right? A must lose every single game. How many ways are there for A to how many total ways are there for A to have a win-loss record? Well, this is just 2 to the 5th, since there are 5 games that A plays after playing the first game, which each of the remaining teams, and so you can think of this as a word. You can think of this as a 5-letter word, where each slot you can insert either win or lose. And so for each slot there are two choices. And so if you multiply this, then since they're independent, you get 2/5. So the number of ways for A to win 0 is 1 and 2/5, and similarly the ways for B to win 0, 1 and 2/5. Let's box this. Okay, moving forward. Now if A wins 1, then B wins 1 or less. Since if B wins 1, then A has a total of 2 wins. Since A beat B in the first game, if B can also win 0. Now the number of ways for A to win 1 is the same as the number of permutations. So we can make a sort of bijection here with the number of permutations of this word, win, loss, 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 loss. And the number of ways to permute this is 5 factorial divided by the number of ways to permute this string of repeated characters, which is 4 factorial. Another way to think about this is just 5 choose 1, which is 5. So basically pick the place for W to go, and there are clearly five ways to do that. That's 1, 2, 3, 4, 5 for each slot in the letter. So there are 5 choose 1 ways for A to, or 5 choose 1 ways for A, let me perhaps write this out over here. 5 choose 1 ways for A to win divided by 2 to the 5th total, and then multiply this by 5 choose 0 plus 5 choose 1 divided by 2 to the 5th. Why is it this? Well, B can win either 0 or 1 games. So since these are 2 independent events, we can add them. They're since they don't overlap, we can just add them. And so for B to win 0 games, that's just 5 choose 0 over 2 to the 5th, as mentioned earlier. And for B to win 1, that's 5 choose 1 divided by 2 to the 5th. So that's that probability. Perhaps we can come to the side and maintain a list of cases. So in case 1, the probability is 1 over 1024. So you can verify 2 to the 10th is 1024. And in case 2, this yields 30 over 1024. Just continue. Now, the rest of the cases are exactly similar, so I'll go a little faster. But if, let's say A wins 2, then B must win 2 or less. So B is less than or equal to 2. Perhaps perhaps this is a more concise notation of what I mentioned here, which I'll use going forward. So if A wins 2, then B is less than or equal to 2. And to calculate this probability, well, using the same logic, it's just 5 choose 2 divided by 2 to the 5th times 5 choose 0 plus 5 choose 1 plus 5 choose 2 divided by 2 to the 5th. And if we evaluate this, this comes out to be 160 over 1024. And the rest is straightforward. I mean, you can just enumerate in the same way, right? The next case would be 5 choose 3 divided by 2 to the 5th times 5 choose 0 plus 5 choose 1 all the way up to 5 choose 3 divided by 2 to the 5th. The next case is 5 choose 4 divided by 2 to the 5th times 5 choose 0 plus 5 choose 4 divided by 2 to the 5th. Obviously, these are in parentheses. And the final case is 5 choose 5, which is 1, divided by 2 to the 5th, times the sum of, as k ranges from 0 to n. And the reason I'm writing it or to 5, and the reason I'm writing it this way is because this is a combinatorial identity that we can use to simplify this a little bit. It turns out that this is 2 to the 5th. So since this is 2 to the 5th, this is 1. So it's 2 to the 5th divided by 1024, which is 32 over 1024. So this is a well-known combinatorial identity. And so let's rewrite all our answers so we can do this lovely computation. So C4 would be 260 over 1024. Case 5, 155 over 1024. And case 6, 32 over 1024. Now if you add this, which I will spare you, you end up getting 638. So the sum, or perhaps we could, yeah, S for sum. The sum is 638 over 1024, which equals 319 over 512. And since this is a power of 2, this cannot be simplified anymore because 319 is odd. So it follows that our answer is 319 plus 512, which is 831.